This video is about concept of moment of inertia from SYJC lesson 1 rotational dynamics. This video is presented by Anita. Concept of moment of inertia. Moment of inertia is quantity analogous to mass. Mass of a body gives us idea about inertia in linear motion. That is, more the mass of a body, more is tendency to maintain state of rest or state of linear motion. Similarly, moment of inertia gives us idea about inertia in rotational motion. That is, more the moment of inertia, more is tendency to maintain state of rotational motion. Definition of moment of inertia. Moment of inertia of a body about an axis of rotation is defined as the sum of product of mass of each particle and square of its distance from axis of rotation. Each and every physical quantity that we come across, we must know its unit and dimension. SI unit kg meter square, CGS gram centimeter square, dimensions M1, L2. Moment of inertia of a body depends upon following factors. 1. Mass and shape of a body. Second, the distribution of mass about axis of rotation. Third, the position and orientation of axis of rotation. Let us discuss in details about these three factors. Let M1, M2, M3 up to Mn be the mass of each particle situated at distance R1, R2, R3 up to Rn respectively from axis of rotation. Then moment of inertia, say I, is equal to M1 R1 square plus M2 R2 square plus and so on up to Mn Rn square. Let us consider this three particle system, each of mass 10 gram, M1 10 gram, M2 10 gram, M3 also 10 gram at a distance of 2 centimeter, 3 centimeter and 2 centimeter respectively from axis of rotation. Then moment of inertia of this three particle system is mathematical formula, very simple. If I call this moment of inertia, say I1, I1 is equal to M1 R1 square plus M2 R2 square plus M3 R3 square. So I1 is equal to M1 is 10 gram, substitute the values, 10 into square of 2, that is 4. 10 into 4 plus 10 into 9 plus 10 into 4. So I1 is equal to 40 plus 90 plus 40. That is 170 gram centimeter square. Okay. Now let us consider same three particle system with a small change. Now see what had changed here. We have moved this particle M1 from 2 centimeter to 4 centimeter. We have moved it away from axis of rotation. Same formula. Let us call this moment of inertia as I2. So I2 is equal to 10 into 4 square, that is 16. 10 into 16 plus 10 into 9 plus 10 into 4. So I2 is equal to 160 plus 90 plus 40. That is equal to 290 gram centimeter square. So it is very clear that I2 is more than I1. We have just moved one particle away by 2 centimeters. And we can see that there is change in value of nearly one. It has changed from 170 to 290. So it depends upon distribution of particle from axis of rotation. Okay. Next, this is a ring. Black colored is a ring. Red color shows axis of rotation. Moment of inertia of ring of mass m and radius r about an axis passing through center and perpendicular to its plane is mr square. This is a disc. Moment of inertia of disc of same mass m, same radius r, about same axis, that is passing through center and perpendicular to its plane, is mr square upon 2. Now for ring, all the particles are situated at same distance r from axis of rotation, whereas for disc, particles are distributed from center up to ring. So here in this case, moment of inertia of a ring is more than that of disc. Now note down this sentence. Among any objects of same mass and radius, ring has maximum moment of inertia. It means for sphere or spherical object of same mass and radius, it can be hollow sphere or solid sphere, right? Ring, disc, hollow sphere or solid sphere of same mass and same radius, right? Ring has maximum moment of inertia. Now next, this is a uniform rod. Here moment of inertia, or rather axis of rotation, is at one of its ends. Moment of inertia of thin uniform rod of mass m and length l about perpendicular axis passing through one of its ends is ml square upon 3. This is formula given in your textbook. Now if axis of rotation is shifted, now it is passing through the center. Moment of inertia of thin uniform rod of same mass and length about perpendicular axis passing through its center is ml square upon 12. Now what has changed here is position of axis of rotation. Now let us sum up what we have discussed till now. Physical significance of moment of inertia. The moment of inertia plays same role in rotational motion as the mass of the body does in linear motion. The mass of the body always remains constant, but moment of inertia changes with position of axis of rotation or distribution of mass with respect to axis. This is all about concept of moment of inertia. Thank you, students. If you have any query regarding this, any doubt, you can meet me in physics lab. Thank you, students.